Okay, the third nucleophilic addition elimination, this time with an alcohol. Getting a little bit harder now, partly because of the nucleophile that we're using, and it's just going to look a little bit unusual in the mechanism to start with, but exactly the same apart from that. So there's our ethanoyl chloride, and I'm now going to draw ethanol, not as we'd normally draw it. So where are the electrons coming from in ethanol as it working as a nucleophile? So it's the oxygen, so I want to almost draw it like water but then add the CH2, CH3. So there's my ethanol, looking a little bit unusual. Pop the lone pairs on, and then mechanism just as the previous two. Have a go. Arrow 1, arrow 2. What will that make? Again, just the same. Let's draw what's not changed. So that's all the same. Single bond to the oxygen again. And then this is going to look a little bit complicated. So to the oxygen, which is bonded to a hydrogen, and still the ethyl group. Now we just need the charges. So negative charge on that one, and positive charge from the ethanol's oxygen. 3 curly arrows, same as before. Let's do 1, reform the double bond, off you go, and then we've only got 1 hydrogen to choose from now, so the oxygen gets its electrons back from that hydrogen. Okay, we probably can't see what the product is yet, but when we start to put this together, so there's a CH3, there's the carbon double bond oxygen, we've lost the chloride, but that carbon is now just bonded to an oxygen, which in turn is bonded to CH2, CH3, and suddenly an ester appears. Seen that before. Can you name it? Ethyl ethanoate. And again, the other product, just HCl. What does a balanced equation look like? Well, again, I've done it in colour so you can see which bit is coming from where. There's our ethyl ethanoate in addition to the HCl. Let's have a go at another one. So methanoyl chloride with methanol. So 2 little molecules now. Have a go at doing this one by yourself. Just be careful with the intermediate, so not many carbons kicking around. Remember, we're making an ester, so this is going to be the simplest possible ester. Got the 2 charges on. Here come the curly arrows. 1, 2, 3. What's that going to make then? So let's draw our ester out. Looks a bit funny, this one, having so few carbons, and that's it. Can you name it? So just one carbon on either side, that makes it methyl methanoate. Again, don't forget the other product, HCl.